Okay, so we have a quadrilateral PQRS. I'm going to draw the other way around.
60-degree angles. Yep, 260 degrees.
Yeah, I'm going to extend it, so I'm just going to draw it the other way around. Q, Q, R, S. So we have SR is 6, RQ is 4. God damn it. Okay, so PS is 5, SR is 6, RQ is 4. Angle P is 60 degrees. Angle Q is 60 degrees. So yeah, I think, okay, so given 2PQ is A plus root B, find the value of A plus B. Again, as Michael said before, this is not because there's like some nice way of finding A plus B from A plus root B. It's just because you have to find the one 3-digit number. So you actually have to find both A and B. For now, let's just call this X. And so what I'm going to do, and what I think was natural to do, almost, was extend this out.
Okay. In general, that's a good technique in Olympia, just extending equal angles, or just trying to complete the diagram.
Yeah. Hopefully the lines are like straight. Not even straight lines. Let's just call this T. And so obviously we have 60 degrees here, 60 degrees here. So this has to be 60 degrees. And we have an equilateral triangle. So since this base length PQ is X, we also have, this is X, and this is X, right? And okay, so now we're gonna use cosine rule, which is something we learned just, yes? Yeah, PS is extended. It's meant to be a straight line. But I just can't zoom out any further for some reason.
You have an arrow thingy that you can use the arrow and scroll it.
Call it straight? Like this?
Wait, oh no, I mean, the scroll on the whiteboard.
Wait, do you not know how to zoom out, or is it just not letting you?
Oh no, it's just not letting me zoom out anything.
Oh, I mean, pressing the arrow. I mean, wait, the cursor, what it's called. Are you on drawing mode? On the thing on the left, there. There's something. Wait, what's thing 2 down from that?
Let's move.
Let's move.
It's a move.
Yeah, but it's just not letting him.
Yeah, 30% I'm kicked out here.
I mean, not zooming or just scrolling with
Oh
them
wait,
up.
it's in options, I think. Zoom out.
Ah,
Oh, what?
Wait, what? You guys didn't know that?
Oh, that's because over the whole time
that's crazy.
people were trying to locate the position on the whiteboard or something.
Are you guys you didn't know that you could zoom out like that?
I knew you could move, but it took forever to move. So that's why I think some people took light years to find the right place or find where on the board.
Rip. Yeah, well.
Yeah.
Rip.
I just try to scroll, right? And then,
Also, yes, you can go to the bathroom whenever you want.
this is. Oh yeah, I'm recording. So freak out for a second. That wasn't recording. Okay, yeah. 60 degrees equal to a triangle. Cosine rule in the little triangle, right? And wait, we have Q. T. It's T.
Okay, let's see. Okay. But yeah, it's an equilateral triangle because there's two 60-degree angles.
Uh-huh. Yeah, so interior sum of the triangle. So that tells us this one's 60 as well. Yeah. In triangle TRS, we have, so 6 squared. You see this color? It's kind of light on my screen. Maybe I'll use a darker color. So in triangle TRS, we have 6 squared is equal to, so this side length, ST, that's x minus 5, right? So x minus 5 squared. And this side length is x minus 4. So this is x minus 4 squared minus 2 times x minus 5, x minus 4, cos 60. So let's just expand this. So we have 36 equals x squared minus 10x plus 25 plus x squared minus 8x plus 16 minus 2 times x squared minus 9x plus 20. And what's cos 60? Didn't even tell me. Actually, no, we won't do that. We'll just cos 60, you know, to be half. So this times a half. Simplifying further, we have 2x, so x squared plus x squared minus x squared, right? So the half and the 2 cancel. So we have x squared and minus 10x minus 8x, that's minus 18x plus 9x, that's minus 9x, right? And then we have 25 plus 16 minus 20. So that's 21 is equal to 36. So I can take the 36 across as well. Make this minus 15. Yeah. Yes. Wait, can everyone else hear me?
Yeah.
Okay. Let's zoom in for now. So what do we have here? This is Did I mess something up? Can I factorize this? I can, right?
Wait. It's meant to be, isn't the answer meant to be a square root? All right. Yeah.
Oh yeah, that's right. That's right. Okay, so we just use quadratic formula. And we get this is what? 9 plus minus root.
Oh no, numbers are a little bit big. Oh, it's not too big actually. Okay. Okay, I was wondering if the answer was guessable because I thought A and B would be small, but it's turning out to be quite big.
Yeah. So wait, 2x, because they wanted 2AP, right? Or 2PQ, right? We go back to the question. 2PQ is equal to A plus root B. So 2x, and x is PQ, right? Because you just have similar triangles.
Should be plus 60?
Yes. Good point. So we have 9 plus or minus, but the minus doesn't make sense, right? Because 9 squared is 81, and we have here root 141. So if we had 9 minus root 141, it'd be a negative answer. And that has a negative length. So we know it's 9 plus root 141. So we have A is equal to 9, B is equal to 141. So A plus B is equal to 150. I think there are alternate methods with like, you can like put maybe like a parallel here. Something parallel to this. And there's like, I don't know, a bunch of 60-degree triangles. Still got to use the fact that cos 60 is half. I just like this one. It was kind of algebraic throughout. I don't know. As for the stats, this was also pretty similar to.
Okay. Wait.
Yeah.
Michael sent me something. He said this question crushed year 8 and below. Estimated year 9 and 10. So people got crushed and decimated by this question. Wait, I'm assuming he's referring to that question. Or is he talking about a different question? Was it? I don't know which question he's referring to, but
on average, like overall, 217 people got this, so even less than question 5. And yeah, it did crush the rates, actually. The rates did better in question 7 than question 6.
Okay, it didn't seem too hard.
But actually, the year 10s did better in question 6 than question 5.
Okay, or maybe it's question 9 Michael was talking about.
Yeah, this question is doable. Yeah, that's it.
Actually, question 9 was really quite badly done, like, it seems.
Oh, really?
Look at the Oscene stats. Wait, is it question 6? No, question.
This one's question 6.
Yeah. Question 6. 217 people.
Yeah.
Oh yeah, there's only 19 solves in question 6. Yeah.
Yeah. 19 curates solved it.
So you might need trigonometry. I think the trigonometry step, yes, you know.
I think trig, I'm pretty sure taught in year 7, like exact angles. I don't know, maybe like the trig and the quadratic
cosine rule maybe.
Oh yeah, they weren't no cosine rule, that's for sure. Yeah.
And also knowing to extend the sides even.
Yeah. And I think even quadratic formula is a bit fringe. I'm not sure. I can't remember.
All right. Oh, year 7 you probably learned quadratic formula. Yeah.
School is treacherous,
Okay.
that's for sure.
Actually, I think year 12 school maths actually had a lot of overlap with first year uni maths, surprisingly.
Yeah.
Literally the same.
Oh,
Statistics is exactly the same in uni and year 12 of year first for so far what I'm doing.
I see. Wait, really?
Yeah, the binomial
Wow.
distribution and we even did the integral. Yeah, we did integral from negative infinity to a normal
Right.
distribution.
Oh, so this is like stat stuff.
Oh yeah, that's
Not for like lineage, right?
I know we didn't do any linear algebra. Yeah, in school when okay.
Okay, yeah, so that's question 6. Pass it over to Yi for question 7.